Hey guys, just wanted to do a video, kind of follow suit with everybody else, kind of showing what I'm doing with the wind turbine these days. So we're running a dual circuit. This is one of the two. I'm running an NPN backwards basically. Pulsing in 15 volt. Today I'll be doing it at 18 volt. You wouldn't think that the 24 volt charged too good, but it actually does from the back spike. So I want to explain the motor real quick, what I'm doing. So these wind turbines have 3 different sets of coils on them. Each set of coils is bifilar. On my L1 here, because you got an L1, L2, and an L3. On my L1 bifilers, I'm using one circuit to pulse one winding in one direction, using the other circuit to pulse the other winding the opposite direction, to give me my north-south dual circuit. Not only is it doing that, but we use the other half of the field on the coil while we're doing this to run a transformer action on the L2 and the L3s. And during the off cycle, in between both flips of the cycle, we actually get to catch the swipe of the magnets during the off cycle. So depending on when you timed these cycles is where the edge of the flux line would break on the coils and the cores. So it's pretty much a pulse motor, a transformer, and a rotary transformer in one. Let's see here. I'm about to extend my L1s here for the dual cycles for 2 more sets of coils on top to do the driver circuit for the outer ring now. Basically, it'll help cut down on my amp draw of what the motor draws, and then we'll get a mechanical advantage from the outer coils here that'll be in series with the L1s. Everything pulsed in unison to make up for some of the drag off of the generator coils. I'm running the L2 and L3s in series through a bridge rectifier here. If I got enough film footage on my phone, I'll show running this light and this fan in series just off the generator coils, no back spike or pass-through current, because these are completely isolated from the driver circuit stuff. So, trying to think any more information to share on this motor at the moment. So, where's my charged battery? This big battery here, the Ford DLT, is now at 12.37. I've got it in series with this deep cycle here and this junk AGM. They don't have much capacity. It has capacity, but not much. So I'm charging in 24 volt right now. This is on this battery currently. I'll start it up. We'll watch this real quick, what this battery goes to. I'll pull just the generator coil outputs off. We'll bring them over here, hook this up. As long as we got the film footage, might have to break it into a second video. So if it cuts off, that's where the second part will come in. So these are just north fields now. I'll be putting south fields in here so I can run the basically the tri-filer coils out here to go with the L1s. My buddy Jeremy, if you got one of these that's wired like this in your garage, like you said when we spoke, I think you really need to try this motor. And our duty cycle is this would be from a north to a north. or south to be in the middle, we're literally running about 1%, 2% per coil. There's 6 of them, so we're running between probably a 10 and 12% duty cycle on a full rotation. I'm going to actually cut that down shorter when I go a little bit higher voltages, because I can get the same RPMs for shorter pulses. Okay, let's get a good look at this. These are Darlington tip 125s transistors. I got some 24 volt Hall effect deals, so I can run them off the same voltages as the transistors. So we'll go ahead and fire this thing up real quick. There's the big battery voltage. This is a wind turbine, so the output on the gen coils normally are 100% RPM based. I can only take the RPMs up so high too, because this thing is way off balance. We've got it wedged against the wall with 500 pounds, and it still shakes everything when you really crank her up. So we'll give her a second yet. I don't know if you guys can hear it or not. And it's kind of interesting, I observed that if you move one timing in closer, that you can get the back spike when it flips for the back spike to be in the same direction as the next pulse, and you get a super boost in the RPMs, but it seems like it draws another 2 or 3 watts more. So we're up to 12.4 on the 4 DLT battery. It usually climbs to about 12.6 and then kind of holds steady. But like I said, most of it's RPM based. So we'd have to get higher RPMs to get a little bit better results on these larger batteries. Once I add the second cycle here, or I should say the other driver coils for the motor, because the real motor's only going to be on the outside of this, it'll really help with that drag that's on the gen coils that they're creating. So it should really improve the motor greatly by doing the outer motor now. Yeah, it's a wind turbine. RPM based, people. If anybody wants to know why I chase like the free energy, clean energy devices, it's more about I want my grandchildren to be able to breathe the fucking air in the world. We drive our cars around all day long and we'll just keep filling the planet up with this shit and be like, oh, it ain't that bad. We'll go park your car in the garage, shut the garage door, and run your car for about an hour and a half or so, and let me know how that worked out. Okay, we've come up to 12.45. I better demonstrate something else here before we run out of film footage. So we'll just, I'm gonna pull the gen charging coils off. I'm gonna have to short it out probably, so the RPMs don't exceed itself. So I'm gonna short the gen coils out. And we'll bring them over here. Put the positive there. Put the negative there. Now we are running that fan. And this LED. You can see it bogged down a little bit. But once we put the secondary coils out here to give that mechanical advantage to the 4-inch rotor in there, that this whole situation will change. This motor should speed way up when you start doing a little bit out here now that this is all balanced in the middle. Now the series batteries are just on the back spike and the push through basically right now. So basically the batteries are running without the gen coils. The gen coils are being burned off right here. I had everything separated, 224 volt banks charging, and I decided to try a whole week of the all on 124 volt bank to see what the results was on that. I've been doing these tests for over 3 weeks now. It's been running at these RPMs for over 3 weeks. I've been adding some solar now from a couple unused panels. During the day, it almost drew nothing from the power source, which was absolutely excellent. So we're still running that load, still running all right. So we'll go ahead and move her back over to where it's supposed to be. Put her there. Put her there. I guess I could show the cap output real quick before I run out of film. These caps are from the generator coils. If I can get it in here. Alright, those are the caps that come off the gen coils to here. So if I remove the gen coil from the battery bank just to the caps, that is 8 3600 UF caps, 40 volters, paralleled, charging. So the output of the motor, just open caps to the gen coils is there. Go ahead and well, guys, that's kind of where I'm at. Like I said to my buddy Jeremy, if you got one of these, I really think you got to give it a shot. I think you got a really good success rate of making this thing mug and just zing, zing. My shafts are bent, so I'm kind of limited. Hopefully yours isn't. Well, guys, I appreciate it if you watched it. If you're interested in this, it's a pulse-assisted wind turbine. Pretty interesting stuff, really, I think. Well, thanks for watching, and this is the Dead End Channel.